All right, let's take a look at the nomenclature of amines. And it says here the IUPAC nomenclature allows for two different ways for naming primary amines. And those two different ways are using common nomenclature and systematic. So when it says two different ways, okay, we have common nomenclature and we have systematic. And I'll explain those as we move through it. But when it comes to naming primary amines, what I say is this: if you can name an alcohol, you can name a primary amine. Anyhow, let's start with this. It says, number one, name the alkyl group ending in "il" followed by the suffix amine. Okay, not too bad. So if you know, or if you can provide a name for the alkyl group that's on your nitrogen of your primary amine, just name that alkyl group. So here we have an ethyl group, so we say ethylamine. Here we have an isopropyl group, so we say isopropylamine. Here we have a cyclohexyl group, so cyclohexylamine. Let's imagine you had something like this, CH3NH2. It's a methyl group, right? So you'd call this methylamine, right? Let's say you had a butyl group. You'd call it butylamine, so on and so forth. But these are all common ways of naming these compounds, and we'll take a look at the systematic in just a second here. So it says here, if you have a more complicated primary amine where you can't just name the R group as some alkyl group like methyl, ethyl, propyl, isopropyl, etc., in that case, it says they are named the same as alcohols, but you use the suffix amine instead of all. So if we go back here, right, if this was an alcohol, and I'll just draw it for the first one, right? If you had this would be ethanol. So we would call it ethanamine. So again, what we have written here, these are the common names. And for the systematic, okay, we'd call this ethanamine, okay? And I'll come back to the other two in just a couple of seconds here. But if we go back and look at this more complicated example here, we name it just like we would name an alcohol. We find the longest carbon chain, 1, 2, 3, 4, 5, 6, 7, right? We give our functional group the lowest possible number, which is 2. So this is a 2-heptanamine. We have methyl groups at carbons 4 and 6, so we have the 4,6-dimethyl, and then we assign the stereochemistry at carbon 2 as R and at carbon 4 as R. So again, the same way you would name the compound as if it was an alcohol. So if we go back here to this one, or to these other two examples, so for isopropylamine, right, if you imagine this compound as an alcohol, and I don't want to muddy up the slide too much, right, but you'd call that 2-propanol. 2-propanol is what you'd call that. And so you could call this compound 2-propanamine. So 2-propanamine, all right, like that. And for this one, if you had the alcohol, you'd call it cyclohexanol. So we'll call this cyclohexanamine. So we'll say cyclohexanamine. All right. So again, both of them are acceptable. The common name is acceptable, but again, the only time you're going to use the common name is when it's some kind of simple alkyl group like the ones that you have shown here, something you can identify quickly. And if it's a larger group that you can't identify, then you have to use the systematic method. And then I've also shown it on here just to show you how it can be used as well. All right, so let's talk about having an amino group not as the main functional group, but as a substituent. And something that we don't get into in a lot of detail in this class is the order of priority of functional groups. But if you have an NH2 group, okay, in a compound that has some kind of functional group that has an oxygen in it, it is going to have a lower priority than that group, like this alcohol and this carboxylic acid. So what I'm saying is this: if you look at the compound on the left here, if you're looking at that compound and you're saying, well, it has an amine in it and it has an alcohol, is it an amine or is it an amine or is it an alcohol? The answer is you call it an alcohol because the alcohol takes higher priority. If you go into the appendix of the electronics textbook, you can find a table that covers this order of precedence, but you see here that the NH2 group is now not the main functional group because it's not the suffix, it's the alcohol that is the suffix. And so that tells you that the alcohol is a higher priority. And so we just number 1, 2, 3, 4, and this is 4-aminobutanol. And the compound on the right, obviously the carboxylic acid takes higher priority. And so we would call this 1, 2, 3, 4. And so we could call this 4-aminobenzoic acid, or you can use para-aminobenzoic acid. Either one is perfectly fine. Now, what if you have an amino group on benzene? Well, in that case, you call it aniline. So you have to know that aniline is this compound here. We don't call it aminobenzene, we call it aniline. And so if you have some kind of derivative of aniline, like the two compounds that you see here, you denote carbon number 1 as the carbon that is attached to the nitrogen of your aniline, which would be your parent. And so you want to give the first substituent the lowest possible number. Well, on this one here, there's only one substituent, so we're going to go 1, 2, 3. And so you could call this compound 3-chloroaniline, or you can call it metachloroaniline. Either one is acceptable. And if we look at the compound on the far right down here, you might have a knee-jerk reaction to say, well, could I name this just by going in the clockwise fashion, 1, 2, 3? Well, the answer is no, you can't, because you want to give the first substituent the lowest possible number. So instead of a 3-ethyl, we're going to have a 2-fluoro, right? So we have 1, 2, 3, 4, 4, 5, and then we put the 5-ethyl first. Why? Because E comes before F in the alphabet, so 5-ethyl 2-fluoroaniline, right? So make sure you're able to name aniline derivatives as well. Now that covers primary amines, but when we get into secondary and tertiary amines, it gets a little more complicated. So it says there's multiple methods for naming secondary and tertiary amines. The first one that's shown here is if you can identify the alkyl groups, right? If it's methyl, ethyl, propyl, isopropyl, or one of the 4 butyl groups, or a cyclo group like cyclobutyl, cyclopentyl, etc. In that case, you just name the alkyl groups and follow it up with the amine suffix. That's it. If the same group shows up twice or 3 times, you just use di or tri as the prefix. Let's take a look at some examples here. Now on the one on the left-hand side here, you can see the groups are a methyl group and an ethyl group and a propyl group. So we just list them in alphabetical order. Ethyl, methyl, propyl, right? Again, just following the EMP alphabetical order. So ethyl, methyl, propyl, amine. The next one is a secondary amine, right? This one was a tertiary amine. Now we have a secondary amine. In this case, we have 2 ethyl groups. There's one here, there's one here. So we would just call this compound diethylamine. Diethylamine, just like that, and you're done. And for the last one, that is a tertiary amine. All 3 of the alkyl groups are the same. They're all methyl groups. So we call that compound trimethylamine. Now, what if you have some kind of chain in your amine that you can't name it simply? Okay, it's not one of the alkyl groups that we've learned. And what I'm getting at is, let's say you have a long chain like this. Okay, now that is obviously the parent. The other substituents only have 1 carbon and 2 carbons respectively. Okay, so what do you do in a situation like this? It says find the carbon parent chain and use the suffix amine. Okay, so we see that we have 6 carbons here. So this is going to be some kind of 3-hexanamine. Okay, so we've got that down. We see there's a stereocenter here, so we can label that. We also have a couple of chlorines, so the 2,2-dichloro. Now, what do we do with the smaller alkyl groups? We've got a methyl group and an ethyl group. What you do is you put the letter N before them, so we have the N-methyl and then the N-ethyl. And that capital N, which is italicized when it's printed out like this, that denotes that the methyl group and the ethyl group are attached to the nitrogen. So we have N-ethyl, N-methyl, 3-hexanamine. And so we ignore the letter N and we alphabetize according to the ethyl and methyl, right? So E comes first and M second. So we have our S, 2,2-dichloro, N-ethyl, N-methyl, 3-hexanamine. And so that is what we do if it's a secondary amine or if it's a tertiary amine. Okay, so this applies for secondary and tertiary amines as well. Okay, so now let's say we wanted to use the longest carbon chain system or the systematic way to name these three compounds here, okay? Now you probably wouldn't do that, but I'm just using these as examples, right? So if I wanted to name this compound, I would definitely call it ethyl methylpropylamine, but let's just see what the systematic name would be. So we find the longest carbon chain, which has 3 carbons. So this is some kind of 1-propanamine, and then we have an N-ethyl and an N-methyl. So if we put all that together, it would be N-ethyl, N-methyl, 1-propanamine. Again, nobody would call it that probably, but that's how you would do it. For the second one, again, it would be kind of silly to do this, but this would be some kind of 1-ethanamine. So this would be N-ethyl 1-ethanamine. Again, nobody would ever call it that, but we'll just put it down here. So this would be N-ethyl 1-ethanamine. Okay. Actually, come to think of it, you don't even need a locant for that since there's only 2 carbons in the ethyl group. So you would actually call this compound N-ethyl ethanamine would be the proper name. So let me fix that. N-ethyl ethanamine. Okay. And for the last one here, all 3 of the groups are the same. So this would be an N-N-diethyl methanamine is what you would call that. Again, I don't know who would use that, but N-N-dimethyl methanamine. All right, so that's how you would do the systematic nomenclature for these 3 compounds. All right, so let's take a look at these examples, and we'll start with the first one. And this one is a great practice problem, C, because you can, again, name this using the systematic way or the common way. I'm going to use the red ink for common, so we'll start with common. Okay, and we can name all these groups. There's a cyclopentyl, and there's 2 methyl groups. Well, C for cyclopentyl, right? The cyclopentyl comes before the dimethyl, right? So we alphabetize the letter C here and M here, so it's going to be cyclopentyl dimethylamine is what you would call this compound. So let me just move this over here. So we'd call this cyclopentyl dimethylamine, like that. For the systematic, so systematic, what we would do is this. The longest chain has 5 carbons in it. So that would be, if you think about an alcohol, it would be cyclopentanol. So this would be cyclopentanamine. And we have the N-N-dimethyl. So we would call this N-N-dimethyl pentanamine, like that. For the next one, the common name is pretty quick. There's 3 ethyl groups, so we'd call this triethylamine. So triethylamine. And if we wanted to give it a systematic name, we could. Okay, the longest carbon chain has 2 carbons. So if you think about an alcohol, it would be ethanol, so it's ethanamine. And we have an N-N-diethyl. So we'd call this N-N-diethyl ethanamine. And again, there's no locant here. You don't have to call it 1-ethanamine because there's only 2 carbons. So it has to be on one or the other. All right, and the last one, we can't give this one a common name because we can't name this as some kind of, alkyl group like that. So we're going to name it using the systematic way. So we're going to start with this as carbon 1 because it's got the amino group on it. So we have a cyclohexanamine. So we have 1, 2, 3. So this is going to be 3-isopropyl cyclohexanamine. So 3-isopropyl cyclohexanamine, like that. Now we have to designate the stereocenter at carbon 1 and at carbon 3, like this. And I'm sure you're all faster than me at this by now. This would be number 1, this would be 2, this would be 3. So at carbon number 1, it's going counterclockwise. So this is S. So we'll pencil that in. So it's 1s. And for the third carbon, I'll use my red pen here. So if we have 1, 2, 3. So I'm just trying to prioritize between these two carbons here. The one on the left is attached to 2 carbons and a hydrogen. The one on the right is attached to 1 carbon and 2 hydrogens, like this. And so the isopropyl group is actually going to take precedence. So we're going to number this as 1, this is 2, this is 3. The hydrogen's in the back. It's going clockwise, and so 3 is R. So there we go. 1s, 3r, 3 isopropyl cyclohexanamine. All right, next question. Draw the structure of each of the following compounds. So tricyclobutyl amine. So all we have to do is have our tertiary amine that's got 3 cyclobutyl groups attached to it. So we'll just put our nitrogen, 1, 2, 3, and we'll put a cyclobutyl group on each one of these, like this. All right, tricyclobutylamine. The next one is 2,4-diethyl aniline. So we'll start out by drawing our aniline. There we go. So there's aniline. Remember, the carbon that has the nitrogen attached to it, that's carbon number 1. So we're going to go 1, 2 ethyl and 4 ethyl, like that. So there's 2,4-diethyl aniline. The next one has some stereocenters in it, 1R, 2S. 2 methyl cyclohexanamine. So what we'll do is what I always do is I always draw them as dashes first. Okay, so there's 1, there's our cyclohexanamine, and we'll put the number 2, we'll put it here. We'll put our methyl group like this. And then what you can do is just kind of test it and say, okay, well, if it's wrong, I'll just shade it in. So if we look at this carbon here, you can see that we go from 1 to 2 to 3, right? So we're going clockwise, which would be R, but we reverse that to S. So this is incorrect. And what does that mean? It means we have to shade this in to a wedge, like that. And if you look at the methyl group, it's the same thing. It's wrong the way it is now. It's as an R, and so we need to shade that in as well. And so there you go. Just kind of a shorthand way of doing that. And so there you have it, 1R2S, 2 methyl cyclohexanamine.